So now, so what can be aspirated? Well, basically, we can aspirate almost anything. Whatever floats in the water can go into the lung. Therefore, foreign material, small particulate matter, okay, or floating matter, bacteria, virus, vomiters, chemical irritant, anything can be aspirated and cause disruption to the lung function. So when this thing happened, it will cause what we call as pulmonary injuries or injury to the pulmonary because of the aspiration, leading to hypoxemia. Okay, hypoxemia or hypoxia meaning that there's low blood in the low oxygen in the blood. Okay, low oxygen that can be carried in the blood, and all of this are due to the alveoli edema, the interstitial alveoli edema, because the high rich protein fluid that pulls the water into the alveoli. Okay, there's a shift of protein-rich fluid from the intravascular to the interstitial space, right? Direct injury to the alveoli capillary membrane and the decrease of surfactant. All of these things will basically leading to hypoxemia or hypoxia. Okay. Now, other changes that can occur due to aspirations are one like electrolyte abnormalities. Even though this seldom significant, and it all depends a lot on the tonicity, how thick or how concentrate the tonicity of the fluid and how much is being aspirated. Whether it's salt water or basically is fresh water. Usually it is transient because normally the kidney can clear all these abnormalities, the electrolyte abnormalities, so it usually transient, unless someone have injury to the renal, okay, because of hemoglobinuria or myglobinuria or hypoxia itself, meaning that renal is damaged, so it cannot clear out all of these electrolyte abnormalities. So roughly what we can say is that if someone have freshwater drowning, they will have low sodium and high potassium, right? And someone who have saltwater drowning, they will have high sodium and high potassium. All right. Okay. There will be also hematologic abnormalities. Hematologic is basically the blood cells. Okay, there also will be some abnormalities to the blood cells. In this case, you will have hemolysis, because if this is fresh water, I'll tell you this now, the fresh water cause this because of different osmolarity. So fresh water will cause a lot of the fresh fluid goes into the red blood cells and it will burst and cause hemolysis. Also, there will be some coagulopathy. Okay, so the clotting mechanism of the blood will be having some problem. Okay, however, it is quite rare. Therefore, in summary, in drownings, few systems can be involved, and I listed here 5 systems basically can get involved. One is the respiratory or the pulmonary system, which causes hypoxia or low oxygen in the blood. The central nervous system, because of the hypoxia, it will cause what we call as cerebral hypoxia, meaning that low oxygen to the brain, and this will lead to edema, cerebral edema, swelling of the brain, and can cause death. Or there will be problem with the renal system, which basically because of myglobinuria, hemoglobinuria, it will basically can cause renal failure. There will be electrolyte derangement and also some coagulation abnormalities. So I repeat again, how bad is someone have the effect? How bad of the effect of drowning? Okay, depends on the insult to the lung system and to the brain system. If the lung and the brain system is insulted quite badly, leading to all of this, then the outcome will be poor. If the insult to the brain and also to the lung is not that bad, then most of the time people will live out of it and they will get what we call as near drowning. Okay, with that, thank you very much.